All right, welcome everybody. Tonight we are going to talk about chapter 2 of Logiciel, which is about basically two dogmas of computational of computation, which I like to frame as what he wants to offer is a computation without computationalism. So he named these two dogmas. One of which is that computation is just the same as what's happening in the mind. And the other is that computation is everything that happens in the universe. So the first one he kind of associates with a few different movements in philosophy of mind in the past, say, 50 years or so. And the second is known as pan-computationalism. So we'll talk, I think, most of the book, most of the interesting stuff is probably about the first, because he's very dismissive of the second point. So he kind of walks through these different talking points in analytic philosophy about. So basically, right after the Second World War, there were all these ideas about how to really frame the mind in physicalist ways. So I think people are getting over their dualism finally. And one of the most popular perspectives is functionalism, which sort of sounds obvious, but people had come up with many complaints about it. So you probably did you study some of this stuff at UConn, in philosophy of mind?
Yeah.
Yeah, this is super popular. It's the idea that what makes something a mental state of a particular type doesn't depend on its internal constitution, whatever that means, but rather the way it functions or the role it plays in the system of which it is a part. And you can trace that back a long way, and now it's pretty popular. And I think it's strange to say this, but I think a lot of the time, just the word function makes people think that this has something to do or is identical with mathematical functions. And so there's like a lot of confusions that you can get into. Because function in the sense of purpose means one thing, and mathematical function means something slightly different, but people kind of mix all this up, especially when you're talking about computation.
It's I feel analogous to the analogy between Landout calculus and Turing machines.
The analogy is between them and functionalism versus
between function and its purpose versus function as in mathematics.
Oh, nice. That's true. Yeah. So I guess to spell that out more, you're saying that the Turing kind of thing is function as mathematical operation, and the more semantics laden thing is like function in the sense of purpose. Yeah. So I'm guessing most of you have heard of some of these things, but if not, this is like a whole rabbit hole of analytic philosophy. And this particular topic comes up a lot here, and I find it very confusing. But it's about where exactly, when you have a mental state, where does the meaning of it reside? Is it inside the state in some sense, or in the relations among mental states, or is it somehow in the relation between mental states and the rest of the world? So the first one, this first option is internalism, and the second is externalism. And a lot of the time in this world, you come across the term content. I still find it very confusing, but it generally means whatever it is that the mental state refers to. So content externalism is the position that our contents depend on in a constitutive manner on items in the external world. And you can kind of see how this kind of comes from a Wittgenstein way of thinking, right? Meaning as usage. And internalism says that the content depends on the properties of the body, or specifically the brain. And so they have a kind of narrow definition of content. So do you guys have a strong opinion on this? I think I was probably an externalist, and I probably still am mostly, but in this book there's a case made for some kind of internalism. Have you like thought about this? Like when we talk in neuroscience about states, we rarely talk about the content in a way that doesn't involve just how the brain states relate to each other. But the fact that they're caused by the outside world consists of the entire, and the fact that they're useful is all you need in terms
What are
of
the different ways in which what are different things state here can refer to?
I mean, considering its philosophy, pretty much anything, right? But what they often talk about states of belief, desire, representation, perception, and thought. So whatever those things mean to you is what they mean by mental state. And you can include mood and emotion also, which are a little bit more tricky in terms of content. But like just think of a thought. Like if you're thinking about an episodic memory, or thinking about an object that's in front of you, or just looking at it, where does when somebody asks you like, what's on your mind? Andrew, you wanted to say something?
Yeah, so I have a question just to kind of like situate. So like, where would postmodernism fit in this, right? So like, my guess is like solipsism is kind of internal because you think that there isn't even any world, there's only this like internal phenomenology of internal states. But in like the people who think that, yeah, the world is constructed, but there is a social process that is part of its construction. Is that that social aspect, is that an external thing, or do you still say that since everything is constructed, everything is synthetic, therefore it's still an internalist view? How would you classify postmodernism in this spectrum?
That's a great question. I think I would
Go ahead.
go for it.
My, again, cursory sort of understanding of like Putnam and all, like the internalist externalist debates would be that like actually it could be either, you could be a postmodernist and be internalist, or like, and you know, believe in internalist or externalist sort of positions on this, right? So like you could be postmodernist and say everything's socially constructed, right? But that could mean that you know, any truth is socially constructed, but we're socially constructing something that relates to states in the external world, or even between me and you, and that's external to me, or it's socially constructed, but that social construction happens internal to me, where my internal representation of one state refers to another internal representation of a state that I have that represents in some manner the thing that's happening that we've socially constructed, right? So I would imagine that you could be a postmodernist and argue either direction on that one. In the same way that I think you'd be like, you know, the only thing that I would imagine you'd be hard pegged on, you know, if you're a solipsist, I think you're clearly internalism only, right? And I think pretty much any other position you could make a case for either internalist or externalist position, or like, you know, position on meaning.
Yeah, I guess the only thing you could say is that sort of based on more like the connotations of postmodernism, that they tend not to want to talk about the brain or plasticity or any of those things. From that perspective, they would tend to draw attention to things literally outside the body, but 100%, you can flip that around and say that the conditions that make that possible are inside in some sense. Yeah. So
are most discussions on this matter mainly with the subject of human mind, or does it also extend to other like animals or whatever?
People talk about it with animals, but I guess because a lot of there's a strong bias, especially in philosophy of mind, to talk about mental states that can be communicated in language, or that are like with photo, that really are just language basically. So but when you're talking about perception and whether perception is representational or not, then you can ask the question: if the dog's looking at an apple and there's a state of the brain, then you can ask what is the content of the dog's Apple state or whatever. But yeah, I don't see in the literature I've seen on this, I don't see animal stuff that much. But if it's focused on perception, then yes, sometimes they talk about animals, much less so than neuroscience.
Which is then mostly external, like internalism, right?
Sorry, what is it?
Perception, like any mental state based on perception anybody that's arguing for a mental state based on perception is probably an externalist, content externalist.
Right. So I think that like the Gibsonian ecological psychologists are a sort of extreme example of externalism, where information already is out there and you're just picking it up, and then there's nothing inside you that actually represents what's outside. So yes, they probably think that's true definitely of animals, and they don't have to worry about language in the case of animals either.
So can you think of, I mean, like, if you're thinking about, say, like both the internal state, but then how that internal state changes, like, or could change relative to all possible states in the external world, where does that fall in?
I think once you throw causality in, it's almost as if intentionality in the sense the aboutness relation seems to vanish for some people. So it relates to this, we often talk about the space of reasons and the space of causes. Like when you explain something, you can either give like a causal story, which is sort of like a temporal narrative, or what a differential equation ideally captures, or you can give reasons, right? Like for instance, if you're using like a minimization argument, or like a Lagrangian or something, right? You're actually using both the start and end positions, like in Fermat's principle or something, to compute the trajectory. So in that particular case, it's not quite a causal story. It's a reason. It's like why the entire trajectory happens. So even like within physics, you can have these two. So what I'm trying to say is that once you sort of draw the causal chain, it's almost like the aboutness relation doesn't even show up in that particular story. So it's like I don't know what to say. Like once you like draw out all the causes, it's like a different kind of story. Is what I'm trying to say. People have tried using evolution to kind of pull these two together. There's something called biosemiotics, where they're like, well, all the aboutness relations are a captured version of like previous natural selection. It is all right, I guess. The Gestaltists have interesting arguments against that, but that's kind of like a bit of a tangent.
We talked about, like you mentioned, Himanshu mentioned like animals. Like now, like since I guess the rise of like the big language models, like those that do like amazing next word prediction, I think it's become like meaningful to talk about like semantic representations in these machines.
Yeah.
And those are, I mean, certainly they're not externalists, right? Because they're not like interacting with the world in any sense. All they have is text and like statistical co-occurrences and stuff like that. And yet they do like amazing things. Like even the really early ones could do like king minus man plus woman equals like a vector that's very close to queen. So it's like picking these of things that refer to like it has the properties that we think meaning has. And so it's like the first concrete example of like things that have meaning that are alien. Like they're not like brain states. They're not like, yeah, this didn't come from philosophy. It kind of came from like NLP research.
So there's a lot of really interesting shit here because, and to link to Jesse's question earlier on affordances, right? There's a sort of question of like, what do language models understand when they appear to behave as though they understand something, right? And so one of the questions is like, do you really understand something if, for example, when I refer to a cup, or in this case, a candle, because that's what I do, but like, I know what this object's shape affords in terms of I can scoop things with it. I can use it to pour water. I can use it to, you know, potentially stack something on top of it, and so on and so on. And there are, you know, I think that the tests of language models are increasingly, you know, instead of the sort of straightforward Turing test of intelligence and understanding, people are reformulating some of those to be more in accordance with, you know, what we think of when we think of understanding and meaning. So like the Winograd schemas, which are already out of date, but the Winograd schemas were like, instead of having a open-ended conversation with a language model and it convinces you, therefore you say it's understanding, you ask a series of binary questions like, the trophy didn't fit on the shelf because it was too big. What was too big, the trophy or the shelf, right? The trophy didn't fit on the shelf because it was too small. What was too small, the trophy or the shelf, right? And so there's no Wikipedia page where there's going to be some, it'll have shown up in the training data set to give you, you know, some notion of the size of trophies with respect to shelves, so that it could actually answer that in a statistical manner alone, but it would actually have to understand something about the nature of shelves and trophies and stacking and so on and so on. And
I mean, these language models are really, really big. Like GPT-3 has probably read the exact example that you like, the trophy in the case example. It's probably trained on that. Like it's
and obviously any of these Winograd schemas that you want to test, you have to test on something it's not trained on. The nice thing about questions like that is it's always easy enough to come up with binary questions that it's probably not seen. Now, one of the obvious issues with language models like that is that children are not receiving a trillion examples of sentences before they can even formulate some sort of meaningful response, right? So the way that those models are understanding is based on deep, you know, sort of statistical sort of linkages between the kinds of words that appear in sentences and the places that they do, in a way that is just sort of unforeseeable. So like, interestingly, there's a debate.
My point here is just that in principle, it seems that things like meanings could reside internally within, like once this model is trained and you have like its word embeddings and you have its parameters, you don't need anything else to get like all these amazing things about meaning to come out of it, like next word prediction, even like using like you can have like a really long context and ask it like, what's the next, like you can tell it like a story, and where the next word prediction task really depends on understanding some parts of the story, and it can do that. So my point is just that you can get very far with content internalism, it seems, if I'm understanding content internalism.
No, I agree with you. I 100% agree with you. So like, you know, my background is RNNs, LSTMs. They were used first of all on language models, and they're really impressive in terms of doing it.
So I would actually think of that as an example of externalism rather than internalism, right? Because the content is not stored in my mind, right? It's stored in physical media somewhere, right? Out in the,
like internal to the model.
but the model doesn't have a mind, right?
The model
I guess
doesn't.
that's the debate, right?
Well,
The model doesn't. I didn't hear what you said.
The model doesn't have a mind, right? Like if I have a trained GPT network, for example, we're not, at least the idea is that we're not already attributing a mind. We can start with that as a starting point and then ask the question, which is fine. But then, because then we can also attribute, you know, a mind to other creatures as well, and other things as well, right? So we can attribute mind to stones as well, if you want to. The question is, and in which case you can then say, okay, there's because a stone has a lot of history embedded in its, you know, in its structure, it has like content internalism in it, but then it becomes a very trivialization of the issue. Then the internal and external blend very easily.
But the responsivity is the interesting thing, right? Which is like the fact that when you're engaging with the chatbot or something, or even just GPT-3, the temptation of the human to say, oh, it doesn't understand XYZ, or wow, it happened, it kind of understands XYZ. That's kind of the interesting thing, right?
But that's again, the human is still involved in the loop, right? It's not like a GPT is asking another GPT something else and making a statement about the response of the other GPT, right? It's still, the human is still in the loop. So as
You can
long as
take
the
the
human is still in the
human-
loop, it will be difficult to completely say that it is internal.
So this relates to something that people did a few years ago. They put two chatbots or even some other sorts of machines together, and then they said, oh look, they invented a language, and it was very dumb because the language was just symbols that were being exchanged, and it wasn't clear that there was any semantics to it. So on the one hand, yeah, you can kind of take the human being out of the loop. And I think this is where the importance of semantics comes in. It's like, what are these systems capable of doing? Like do they have any? Can they maintain a goal? And those kinds of things, and perform so I think it's a moving target actually. Rather than saying we want to pick the Turing test or the Winograd schemas or whatever, it's like every time we see one of these things, we're simultaneously impressed with it, and also we're like, we kind of want to redefine what it is that human beings are doing, because
That's
like, there's
that's definitely
clearly
true. And I think in the limit, what we ultimately all are basically getting at is how do we distinguish between something that understands and something that behaves as though it understands. Right? That's the real question. How do we distinguish between something that's so good that it acts as though, like, it's, whatever sci-fi movie you choose, it acts as though it gets it. It tells you that it feels it,
Why is there, what's the difference between those though?
and that's the question. Is there a difference?
No.
Is all it comes down to that you can perform as though you understand. And this is Searle's Chinese room, right? Like, that's the whole idea of Searle's Chinese room. Does it matter? Like, does it matter whether or not if I'm just following a rule book? And
No, but wait. But I think like in that question there is like implicature, I guess, a presupposition that actually there is a difference. Like you're saying, does it matter between those two things? But what if those two, there isn't anything to matter? Those two things actually are the same.
No, So I
well,
agree. There's an argument to be made that there's no difference. All that counts is behaving as though you understand to the end.
Well, there's a difference between being able to kind of address like 99% of example like prompts or whatever, like and 100% of them, right? Like that's the understanding is, like with mistakes like aside, like if you really understand something, then it's not a probabilistic thing, or at least like it's a probability one sort of thing.
But humans are not so great also, right? Like,
oh yeah, but I mean like but human mistakes are like different than
I agree.
than machine mistakes, I think.
I think you have to go with, like, when you don't have a formal theory, you kind of have to go with this intuition, right? That there's something wrong with even these, like, I played with GPT-3, and like there's something, like, it's impressive. And what I find most impressive about it is how much structure there is in the statistical corpus. Like, for me, it's fun to just sort of query the statistical corpus and find out, oh wow, basically the structure of what is a grammatical sentence is somehow sitting in there. And also, I mean, it has memorized vast chunks of text. So you can actually, with the right prompt, get it to actually spew like the entire text, like verbatim. So those things tend to convince you that it is not, it doesn't have understanding. So it simultaneously does things that humans cannot do at all. And you can't teach it a game. Like, you can't like chat with GPT-3 and say, I'm going to invent a game here right now. You have to play with me. So, that the 4-year-old can do that. So yeah.
One thing with, like, I remember arguing with, like, Andrew, I don't know if you remember this, but like outside the UConn library, after fucking 3 a.m. or something, arguing about Searle's Chinese room. I remember we used to argue about this, and the position, I don't know if it was both in our position, my position, but like, I remember the position of like, if it performs to the end, in the limit, as though it understands, then it must understand, right? Like it won't be able to perform and answer any arbitrary, question or do any arbitrary translation if it doesn't truly understand, right? And the interesting thing it feels like is that we've gotten to a place where the language models, where we were, 20 years ago, where we're starting to say, okay, we're close to the limit of being able to distinguish between, I know a lot of dumb people, for example, right? Like they're not going to be able, granted, the Facebook bot sucked, but GPT-3 and its
amazing.
predecessors are like quite good, right? And so, yeah, there's a hard question of like, does it even mean anything to ask, does this understand relative to humans if it's functioning and behaving in a way that you can't distinguish, right?
Because that's how we treat humans, right? Like we
Yeah.
see,
Well, but
can,
I guess, yeah, I agree with this point. I think like, why do we actually believe this is a meaningful question? Like, why do we think that there is something that we have that we call like the understanding that is anything different but our ability to behave as if we understand? Because if I would argue that actually, if there is any aspect of a reality to it at all, to this like the true understanding, if there is any, then it has to be observable. Because if it's not, then it's not, then it might as well not exist. So just like by Occam's razor, you kind of have to say that we like the human beings, our minds do not have any understanding except the one that can actually be transmitted to the outside world, and that can be observed and distinguished from like not having it. So I think if you like really commit to like this scientific principle of parsimony, you just have to say that, yeah, we are as external and behavioral as the robots are, would be.
is Wittgenstein's beetle, right?
The one thing I would add is also that like the thing that 20 years ago I sort of thought would be the distinguishing factor, and I still think might be, is the ability to talk about arbitrary things in a way that a language model wouldn't have, right? Like I can say to a person like, hey, it'd be interesting, like let's test, can you do this thing with a thing that you would have never expected, and it's totally unremarkable, but because you're an embodied agent and you've played with the thing and you understand its physics and you've seen it and you've experienced it, you'll be able to, have a simulation of like what that looks like and be able to respond in kind, right? Whereas a language model that hasn't actually physically, like it hasn't smelled the thing and hasn't touched the thing and hasn't used the thing, is never going to be able to like, actually answer all of, or riff or have a discussion about all of the arbitrary things that we might want to bring up. And so the point I always had with the Searle's Chinese room shit was always just like, it's not going to work unless it's embodied and unless it has a means of actually getting to understanding in a way that we're referring to when we're talking about like human understanding,
Yeah, I think that the type of understanding will depend on the training. So it's like not clear. It's an open question whether you can bolt a system that has like a physics engine or something, or like some separate perceptual system to GPT-3 and somehow get the two types of knowledge, if you want to call it that, to interact with each other. I think that's very much an open question. I doubt it will work though, but it's almost like internal prompt engineering. Yeah, so that was a sort of internal external thing. And then there's this other kind of perspective called eliminativism, which used to be pretty popular, right? You don't hear about it that much anymore. Which is so this is a diagram from Wikipedia of folk psychology. So when Himanshu asked what are some mental states, a lot of the time in this sort of analytic pillow world, they'll talk about beliefs, desires, intentions as folk psychological mental states. We tend to use them when we're thinking about ourselves, and we tend to use them when when explaining other people's actions. oh, he did this because he believed that, and so on. And the eliminativists, such as the Churchlands, are not having any of it. So they want to say that the ordinary common sense understanding is deeply wrong, and that they don't even exist. There's no such thing as a belief. There's no such thing as an intention. No such thing as a desire. And like even Descartes didn't go that far. So the caricature, which I think maybe Patricia Churchill once said this, is like, he's like comes home and says that my dopamine levels are down and I would like to boost my oxytocin with a blah blah blah. Like so basically replace all the traditional mental categories with neural categories, which are purely causal and don't have any content, meaning they're not about anything. There are lots of problems with this, but it relates in a way to what at least sometimes Cavia attributes to Chomsky and someone named Stich, which is that a pure semantics of computation. So now we're getting to the point that the same ideas about the mind you can apply just to computation itself and say, is the meaning of a computation inside the computation or in relation between it and something else? And so with language, which shares many properties with computation, at least in a formal sense, people would say, well, all you need is syntax, and whether the things that are being moved around mean anything or not doesn't matter. So here we come to the book itself, and so the RTM is the representational theory of mind, which colors a lot of people's ideas about what the word representation means, because it's a very language-oriented notion of representation. So so in this kind of purely syntactic perspective, you need that computational processes have access only to the formal or non-semantic properties of the representations over which they're defined. Even calling them representations at that point is really weird. But I myself have not read enough Fodor, and I find it very difficult to read Fodor. It's a very strange way of thinking. But he's very convinced that eliminativism is a bad thing, and that saving folk psychology is almost like a moral imperative. And he thinks that a representational theory of mind and a computational kind of framing of how representations interact with each other is how you do that. You say that beliefs, the way that beliefs, intentions, etc., enter into relations with each other is computationally. So here's where he makes these Cavia they make these comments about Turing orthodoxy. So a more extreme rendition of the syntactic argument can be located from within computer science itself, a view I call Turing orthodoxy, the reduction of the computational to the machinic in a resolutely physical interpretation of Turing machines. This position finds its contemporary philosophical expression in the work of Piccinini, who offers a purely mechanistic account of computation. So he's trying to distill the semantic from the computational, or to separate out the two, leaving a mechanical residue to be distinguished from both the syntactic and the functional, endorsing the multi-level part doesn't matter too much. So here's where Cavia states their position. Since it's my position that computation and inference cannot be decoupled, that computational explanations necessarily bear epistemic content. So where do you guys stand on this? Does computation carry any meaning, or do you like to go with the sort of empty formalism approach, which is that there are these things that some people call symbols, but they don't stand for anything. They just have like rigid law-like relations with each other. That's the position that Cavia does not want to endorse, but it's, I think, the default. I definitely thought of computation that way 6 months ago even.
It's like, why would you want the lesser thing?
Which one's the lesser? Which one's the lesser? No, which one in your mind is the lesser?
Well, yeah, what?
Well, as in having a case where computation is just
Empty
representational, right? Yeah, empty, as opposed to
No,
one.
but I can have a random. I can design a random algorithm that I don't understand what it's doing, but it's enacting. It's a process, and we can come up with some meaning that we want to imbue onto it, but I can come up with that machine. Right?
Yeah.
That's a
Actually,
computation.
how does one do that actually?
You
What do you
you come up with a machine
You
that
come
goes,
up with a Turing machine. If you think of it as a program and like, you know, maybe some state that it's reading as a starting state, enumerate. This is the thing that Jürgen does, is that say enumerate the programs. And you like
Oh,
you
all
can
possible
literally enumerate programs, right?
Mhm.
And all of the programs that you could imagine being enacted will fall out of just, you know, stepping through, programs of varying lengths or of increasing lengths.
Yeah, in lambda calculus, this is called a universal generator. There is like a single lambda term that can be reduced to have every other lambda term as a subterm. And so since every algorithm is representable in the lambda calculus by the Church-Turing thesis, then yeah, basically this one single term contains every possible algorithm that can be written.
Right. So I guess the main complaint with these types of frameworks is they cover too many things that don't have any particular bearing on what people want to do with computation.
yeah, it's like,
What does that mean? No, but what does that mean?
no, yeah,
What people want to do with computation?
Meaning that I don't want a random state generator, right?
like if I give you,
You can't really do anything with it.
Hold on. That's
an example, right? If I give you an executable file that when you click on it, nothing happens. You don't know what's happening, right? What values it?
Does that mean it's not computed? If I give you a mathematical equation that you don't understand, does that mean it's not mathematical?
Yeah, I mean, it can be garbage, right?
Get the fuck out of here! Get the fuck out of here!
No. It's
Get
like how is he
the-
supposed to know without? So
Yeah.
He's
this is the whole
not
point,
supposed
right?
to know.
This is
He's
the
not supposed to know.
constructivist
But
thing.
if it's doing something, then it's mathematical.
I don't know if it's doing anything. It could just be Greek letters, right? I have no idea what it means.
But you don't have to know. That's the beauty of the Turing machine approach. It's doing something or it's not doing something.
Right. So we might as well just talk about these three objections, which are the main kind of controversial part from the perspective of theory of CS. So this is what we were going to kind of talk about, but yeah. So does mechanistic imply that every physical process is a computation? Like based on that very logic that you just said, Saurabh. So that yes, right?
Yeah,
I mean,
you guys know about
incorporate-
this.
Yeah. So he has a problem with this. It's not about whether that's like once you start with that assumption, you can just go with it. But so he's saying that there isn't any semantics, meaning that none of like the majority of these random programs have no semantics. They don't mean anything. And then there's this, it's an interesting issue, this Tarski's undefinability issue, is that you in order to actually do certain important things, such as determine equivalence and equality, you actually do need something from outside the formalism itself to determine what's equal to what. So that's something that the type theorists seem to talk about, and he's going to try and use that type theory approach to come up with an internalist definition of computation that has semantics loaded in. And then the second complaint is that any account of computation needs to specify in a convincing and unambiguous manner which transformations are computational in nature and which are not. So if you think that every single process, by definition of being a process, is a computation, you don't have to worry about this. And this Piccini as kind of uses multiple realizability as an argument. And part of the reason for this is for people who don't want to say that all processes are computations, you might want to say, okay, like the stomach, is the stomach computing anything? And then you could kind of go in the direction that when I want to say sort something, I can actually do the sorting in various different ways using different physical substrates. Whereas with digestion, there's not that much space I have for changing the physical substrate and doing the same and performing the same function. So here's where the function comes in.
What? No. What? We do like modern bio, like we can replace parts in humans with non-biological parts, all like hip replacement. They're not replacing it with another human hip, you know? Like there's a future you could imagine where they replace your stomach with an actual thing that just does what a stomach does.
But was that really
Right.
computation? Like,
Well,
do you
it's the
expect
multiple
to
real.
replace
No, it's the
a
multiple
stomach with a
realizability.
computer, or
No, it's the multiple realizability part of it, right? Like you can realize the system with that's not a stomach you've replaced the thing with. It's a different thing that's performing the function of what the stomach was performing, right?
Right. So what you're saying is that multiple realizability cannot distinguish between any functional process. Like as long as something has a function and it's not magic, you can replace it with a physically distinct thing and it'll perform the same function.
My
Right.
position is not that you can always do that, but that it's not the case that like, you know, it seems, and again, to be fair, I've not read.
I mean, you'll disagree with it because he's starting from the assumption that I don't.
what are you
anyone doesn't want-
disagreeing with, Saurabh, over here?
So the position, for example, that, you know, a stomach is an argument against multiple realizability, I think is ridiculous.
Wait, I don't understand that argument though. As in, I don't understand what the stomach can. What is
Well, the
That's
stomach's not a computer
That
because it
comes
can't
up
be
here. I didn't
replaced.
bring the quote up, but it's somewhere here.
Big-
Um,
say it again, Saurabh?
So it sounded like what Johan was saying was that Cavia's position is the stomach's not a, you can't think of the stomach as doing a computational process because it's not realizable by anything else but the stomach. And actually, I think that's silly because I can imagine very easily the stomach being replaced by not a stomach and some,
Mm-hmm.
you know, technologically advanced thing that does what the stomach does.
yeah, so here's the bit where he comes up with that example. So here's the general kind of concern here. It's typical of analytic philosophers, which is that you want to kind of individuate computations. So like it's the standard move that I make, right? Any description that applies equally to everything in the universe is a useless description. And I definitely agree with that. Like, so further constraints are needed to properly individuate computations. Consider a stomach, an organ which by definition plays a functional evolutionary role in an organism, digesting food, and has a mechanical basis, but is widely considered non-computational in nature. I agree. I don't think most people would think of the stomach as a computer. Here, Piccinini distinguishes the biological from the computational by introducing the notion of implementational vehicle. Computational systems are those that exhibit the function, quote, the function of manipulating vehicles that are defined independently of the physical medium in which they are implemented. Like, can you define what a stomach does independently of the physical medium? Completely independent. So you can't mention carbohydrates or anything like that.
Yeah.
I think the answer is no.
Sorry, no, I don't agree with you. I think
You would have to find something that's like
I think-
similar to what a
well,
carbohydrate is and does and like all that kind of thing. You'd
Yeah,
have to
yeah, I
find
think-
you'd
I
have to
think
find like a perfect analogy between like what
Yeah.
these things are.
No, I think the question is not that can you do it, is do we have such a model yet today, right?
Yeah, and do
No,
we
no,
think that
no, that's
think
not
that
the
and if
question.
and if
No,
that wait hold on a
no.
second hold on a second if you can say that the stomach is doing something that is computation, then is that going to be akin to what we think of in terms of what the mind does in, like, if we're going to call what the mind does computation? Like, are those two things the same?
I think the
Well, I think
huge mistake that Cavia makes is talking about, you know, computation in the mind. And computation in like there's a huge
But if everything is
conflation.
computation, then
Okay,
surely
we're
the
gonna
mind
switch
is
it,
too.
right? This is not
Yeah.
about computation as a mind again. This is about
Do you think the
This is
stomach
not
follows
the-
processes? Do you think the stomach follows a process? Do you think the stomach follows rules? For example, your stomach is not going to blast music every time you eat a grape, right? Your stomach is rule-based. It's a process-based system. There's input, there's rules, there's it's stomach components. Yeah, the stomach does what the stomach does. Why is that? Because it's programmed to do what the stomach does.
That's the sort of
That's
the
the
next
way you
thing,
need
which
to think.
is-
That's the way you
So
need
that's
to think
yeah.
computation.
That's the standard vacuous notion of computation because it
Well,
doesn't make any
no,
distinction.
no. It's easy to say it's vacuous, but it's but if you already don't agree with it, then you're not.
But it is
agreeing with-
vacuous, right? I mean, that's literally what vacuous means. Right?
Okay.
It makes no useful distinction.
Yeah, okay, I have a question. Johan, you
Yeah.
seem to be reading this book pretty closely, right? So
Yeah.
I haven't read the book, so could you just like distill, so what exactly is Cavia's critiquing and what is the position, like in one, I don't know, like in one sentence, like what's the position he's trying to, I don't know, refute or
Well, he's basically trying to say that I think I'm not 100% clear on the critique of Turing machine, but I think it's that precisely that it covers too many things that don't conform to a more narrow notion of what actual computation is. And yeah, Himanshu, would you add anything to that? Like so
I think
he
that
wants to
that's
say
first,
that
the first, part of that first point over there captures most of the critique, right? That it suffers from, an adequate stance on semantics.
wait, could you repeat that?
The first point that is on the slide.
yeah, so the idea that there's an inadequate stance on semantics.
Okay, so he wants to put semantics back into the Turing machines. I don't know how I feel about that. It sounds to me, I know my first impression, I'm sure I'm totally wrong about this, but my first impression is like this guy sounds like a kind of like computational fundamentalist, how like, but instead of like using computation to demystify, the mind, the physics and so on, he's actually mystifying computation and making it this, weird, unknown thing.
Well, it's the opposite, right? It's the opposite because by giving something a semantics, you're making it less weird. Like you're trying to.
I think the
show
point is
why
that
it's reasonable.
if I wanted to use computation to demystify something, that I should avoid using Turing machines because of their inadequacies in capturing semantics properly, and that I should use something that's better adapted for it, like lambda calculus. Is sort of the stance.
But if you're trying to understand the mind, you should neither use Turing machines nor lambda calculus. Probably.
I agree with you on that, but that's a separate matter. But he's not focused on the mind. His is a.
No,
is
but
a-
that's
what
one
should
of
he
the
be
two
doing?
things.
What should he be doing?
I think if you wanted to understand the mind, then there's a lot of interesting questions to ask about sentience, reasoning in humans, not reasoning in logical systems. That totally sidestep any questions about Turing machines or lambda, or recursive functions in whatever other representation of computation that you might have. I don't think thinking about the mind as computation is useful. Nevertheless, as a question of what computation is, I think computation encapsulates all that. Doesn't necessarily, in the same way that, for example, it doesn't necessarily make sense to talk about biological phenomena by
That is part of
reference to quantum mechanics.
I think that is part of
it's the wrong levels.
I think that's part of their point that it's very easy for people when they start talking about computation to end up talking about the mind, and that's what part of the critique is, that we should avoid that, right?
But
like
But I don't think any of the
is-
people that talk about Turing machines fall into that
So-
trap.
But I think it's not just Cavia, meaning I found this pretty good paper by John McCarthy that kind of makes a related argument, maybe more grounded in practice. This is like any programmer who has also had to write down Turing machines to compute functions will observe that one has to invent a few artifices, and that constructing Turing machines is like programming, and that there's some issues practically, namely the control flow is described awkwardly. So the reasoning, which is really what Cavia's focus is kind of opaque. Like you can, yes, in some non-constructive sense, name all the programs, but it doesn't help you in the actual design of something useful.
But here's the thing,
made, yeah.
like, I think in the reason that this works, when did McCarthy write this?
1961.
Yeah, so we're talking like a decade and a half, maybe, after Turing machines were proposed, slow, like there was no internet, you couldn't just get new papers. All that shit was slow to propagate. But it's not like anyone growing up today, going through a computer science program, has the impression that Turing machines are the right way to think about algorithms in a general sense, right? Like,
right.
You design you design Turing machines in a computational theory class just to get some experience with it, and then you say, okay, but now we're talking about graph algorithms or sorting algorithms or X, Y, and Z, and no one talks.
No,
And that's kind of the point.
who goes through a CS program, right? But that's not everybody, right? People who have never gone through a CS program do not.
But the people who don't go through CS programs don't talk about Turing machines.
Well, that's the point. Like they do, right? We see
Well, they do, right?
is
Cool.
everybody talking about Turing machines, right?
Cool.
And
People have said even like the DNA is the Turing machine or something like that, right? Many ridiculous things have been said, and people have used Turing machine arguments for the mind. Like it's like common, right?
like I talk about Turing
Um,
machines, and I've never taken a CS course.
Doesn't Daniel Dennett talk about Turing machines?
Exactly, plenty of people talk about it, so that's like a non-starter. But
No,
that's like a totally waste of time point. But like,
I don't think
but
Dennett's like
here
I think a lot of those people maybe reference Turing machines in very sort of
sure, that's fine.
tangential ways, but like I don't think it's the core of anybody's argument.
So well, all he's trying to say is that maybe the so-called foundation of what computation is not a particularly good representation of how computation works in practice. And like you said, hey, the CS people already know that practice does not resemble theory. But maybe for a wider theory, you need something else.
There are papers that he has cited about pan computation, right?
Yeah, which we have, like David Deutsch, for instance. So and here actually this mind thing, you can't avoid it, right? Because so the subject of computation is essentially that of artificial intelligence, since the development of computation is in the direction of making machines carry out ever more complex and sophisticated processes, i.e. to behave as intelligently as possible. So this is, I think, the kind of connotation of computation that I think Cavia is going for, not random states being led into other random states, because which has nothing to do with behaving intelligently. So
here's the problem, but like this is McCarthy's like saying, hey, here's what I think computation is about, but it's not the actual like definition of like, here's all of the computational like Turing was like, hey, here's the definition of computation. If you can think of anything that can't be represented in this way, that's, algorithmic or whatever, then fuck me, right? But like McCarthy's just being like, hey, this is kind of all pointing in the direction of, what we think of as intelligence, but
that's what the computers are for, right? Why else are we using them?
But it's not what computation means, or it's not what computation is.
Why not?
I would just, by the way, I would say that like, yeah, from a mathematical point of view, computation, there is no physical or mechanical aspect to computation at all. Computational, just sometimes you want to know like what functions from integers to integers can be like effectively computable and recursive, like computable. That's one precise definition. What makes a Church-Turing piece, the Church-Turing piece is basically just a definition for what it means, like for a function or a set or whatever to be computable. The thing what makes it a little bit weird is that actually we had, before that concept kind of was put down by Church, Turing, and so on, that we actually had an intuitive idea of that, right? So like somehow we already had, like back in the Greeks, you know, like the division algorithm, like we have an intuitive notion of an algorithm. But from mathematical point of view, it's just a definition. There is no, it's not saying anything about the world. It's not, there is no physics to it. There is no, it's just like a property of abstract objects, like functions from integers to integers, or subsets of strings, if you don't want to talk about decidable languages, or, you know, that just other formal objects. It's not like, there doesn't have to be any like cultural or physical or real aspect to it.
Right. So you can make the claim that computation has no meaning also, but this book is about the case that there should be a philosophy of computation, if you like, not a mathematics of computation, for what constitutes computational reason, basically. So yeah. I like this part also, which is about, again, related to kind of the goals that overlap both with artificial intelligence and with what needs to happen with even neuroscience, is you know, this encoding of common sense, which relates also to this the what is it, GPT-3 and all of that. So we need to devise suitable formal languages covering the subject matter about which we want the program to think. And mathematical linguists are making a serious mistake in their almost exclusive concentration on the syntax and even more specifically the grammar of natural language. So I think this sort of fits with the general point that the purely formalist approach doesn't actually get you at meaning or sense, and that there is a version, or there's a way of thinking about computation that where potentially, because this is what he's claiming about type theory and stuff like that, where the semantics is kind of built in. It's a very restricted semantics for now, but which captures something about how reasoning works in computation. Right. So back to Cavia. So
I just
people who,
sorry for interrupting, but can you go back a slide?
Yeah.
Yeah, did you mention the codex, the like basically the ability for GPT-3 to write code from declarative sentences?
oh, right, yeah, I've seen that.
Yeah, yeah, it's incredible. Like you can give it like just like very high level instructions, and it can. Sorry for interrupting.
Right, but yeah, again, I guess the statistics of the annotations and the comments and whatever contain all that, which is pretty awesome. So this I like a lot, because again, I'm not a pan-computationalist. I don't think everything is computation. So I think what marks out something as computational involves some sort of teleology, meaning there has to be a purpose. Yeah, so he'd spent some time arguing with Piccinini, who has this other kind of purely empty formalist definition, which isn't pan-computationalism, but there's a circular definition. One of its teleological functions is to perform computations. Like for a computer, this is that. So what did I want to say? Yeah, so this is the point which I think is useful, which is you kind of want to make a distinction between diverse functional mechanisms, like a hydraulic suspension system of a car, a fan, and computation itself on teleological ground.
What is it?
And Piccinini makes this optical realizability argument.
What does it mean for it to have a purpose?
To be part of some, well, we get to this eventually later, but to be part of some inferential or like like however it is that we use programs, right? We're doing them with some goal in mind, and that goal is the purpose.
It seems, yeah, that to me is a huge failing on any definition of computation, where like if you're saying that it has to be purposeful or intentional or then
But that's how
it
we
just-
use computation.
no, I don't
Like
think so.
we encode like purposes in it, right?
No, I think there are computations that will,
That's how we use computers.
that's not, yeah, exactly. Yeah. I think we will find computations that are useful to us, or computational processes that are useful to us, but I think saying that it's only a computation if it has a purpose,
So for
it doesn't
you,
even make sense to me. Like,
so for
like,
you, computation is essentially an analytic exercise, right?
no, I mean, what if I said to you, here's a function, input output, I don't know what it does or why. Here's but there's a
just
function.
mathematical function, right?
Yeah. I can't tell you what it's for, what it does, or why.
Like square root. What
Would
does
you
square
say
root
it's
do?
not?
Like
Yeah,
square root is a
would you
function,
say?
right? So it's-
Would you? No, but forget about square root. I don't even know. It's a black box. There's a process. There's a function. There's not.
Mhm.
But I can't tell you what it's doing or why. But every time you put in the same thing, it gives you the same output. There's a process that it undergoes to give you the output given the input. Would you say that that's not a computation or a computational process?
Yeah, I would say it is not a computation. Like it's a black box, right? How can I say it's anything? Right? It's not a black box if you can say it's computation.
Wait, like if you randomly initialize like a neural network, let's say, and you give it an input and it gives you an output, and you don't know what, I mean, the function is random.
It doesn't mean anything.
But if it's a neural network, then I will admit it's a computation, right? Because you have
If
told
it's
me
a random matrix multiplication, is it a computation?
yeah,
What's its purpose?
don't know.
And if you don't know, then it doesn't have a purpose. So why are we defining whether or not it's a computation based on whether or not we can?
Well, I don't think there's I don't think there's an attempt made to give a closed form definition to the word computation. More like generally when people use computation, it is not to just randomly multiply weight matrices, right? It is towards some end.
But this is a huge departure from what the point of defining what computation or,
But there's no
algorithmic.
attempt to define computation here in this book.
It's an attempt to claw back the definition of computation or algorithm from what was set forth by Turing and Church, right?
Oh yeah,
It's saying it's saying literally, Turing, hey, it was a cute job you did there, but applied to way too many things. You allowed computation to define random stuff and non-purposeful stuff,
It is
and therefore
not making a critique of the Turing model. It is making a critique of how some people have universalized the Turing model.
no, you can have a random Turing machine, yeah. Would Cavia say that that's a computational process if it's random?
Very likely, yes.
No.
Would it?
And again, I haven't read any of the books, I don't know,
Yeah.
but it
so
feels very strongly like no.
like Cavia is a computer scientist by training, right? So would definitely say that any Turing machine is a computer. So I think,
but he does want to say that a theory
Has
of
to have meaning.
computation should have semantics, and that the operations should have semantics. So he's wants to
it's not a theory
supplement.
of computation, right? It's about a theory of computational reason, right? And not all computation is necessarily reasonable. And the things that are of interest to us are the ones that are the computations that are reasonable.
Right. The book is called something about computational reason. So
Yeah.
But then that's just basically, that's a
Now
very
the question is-
wishy-washy. That's
now-
not
Now
taking
the
any
question
sort
is
of,
like, what is the line that you draw around what you might
Well,
want to call something as reasonable or not, right? And that's the
no, but
exercise.
then the claim there is that the only computations that we should care about are the computations that we should care about, basically.
Well, we don't want to land there, right? So we want it to be more meaningful than that. So
No, but that's Cavia's position according to you.
no, I think Kavia's position is to outline what that space is. Of all of your Turing machines, take your Turing machines even, right? Of the space of all your Turing machines, which ones are the ones that are actually going to be of interest to you, that you want to like double click on?
So again, I read the
the focus
the
is
intro
on the
portion.
reason part, definitely.
I read the intro. It sounded to me like Cavia wants to define what computation is and to sort of draw the boundaries in a way that says, you know, like computation is the set of things that, like, you know, we can ascribe meaning to, or like, you know, purpose to, or something along those sort of lines, in a way that like random Turing machines would not or should not be considered computation. That's what the intro sounded like. I'm not sure if that's what the rest of the book sounds like, but it had a very strong
More or
feel
less,
of that.
because the focus is on semantics as the key idea in, like Himanshu said, maybe it's not just computation, but computational reason, you know. So this, I guess, everybody is familiar with, but there's an issue when you just mentioned how symbols relate to other symbols. So for instance,
Wait, I do have a question, I guess,
Yeah.
about that. So you are saying that he wants to bring semantics back into computation. He thinks that like the disregards of semantics and like the George Turing, the mathematical view of computation is like a bug, not a feature. And
Right.
And basically he wants to kind of, yeah, like say that those things are, well, I don't know if does he also want to use computation, like are those things gonna be mutually defined, like the semantics and the computation? Is he also going to like use computation to say what the semantics is?
Not exactly. It's more like the way that basically homotopy type theory and kind of bakes the semantics into the operations. He wants to contrast, and he does that in later chapters, between a kind of formalist, like David Hilbert style axioms plus logic approach, and something that is more constructive and where the moves are not simply logical but have a kind of meaning.
Okay. Okay, so first of all, I really do have a problem with using the words, the way semantics is used there. But this does remind me of Martin Lofminian explanations, which was basically that's, yeah, like the logical operations are not like in Tarski, there you have like this external world and you kind of evaluate your formulas in that external model, right? The matter model. And in type theory, yeah, the minion is kind of the computational processes that are going on in mind as you are validating certain inference, like certain type in judgment, actually, like to prove that, like, I don't know, factorial of 3 is a natural number. You need to know that factorial is a expression that takes natural numbers to natural numbers, and you need to know that 3 is a natural number, and that's using the application rule, you can there is computation, and in a dependent type theory, there is a lot of computation involved, because you might have to like perform substitution inside a type to check, and you might have to perform like actual computation in the course of making that judgment. But I don't know if semantics, like when people use the word semantics, I almost kind of default to this like Tarski view of the external thing. And I think the point is in Martin Love, it's not external. It is actually like all the like the meaning of the proposition is basically completely bootstrapped by your own like internal cognitive apparatus.
That is exactly what his goal is, to do that, what you just said. And so he does actually, to basically to kind of maybe take that insight, which is already present with the mathematicians seem to already kind of get this, and kind of bring the philosophers on board, or whoever ends up reading this book. So I guess the other way of doing semantics, which I don't know enough about that, which is the model theoretic approach, which is what comes from Tarski, which is like, given an expression, which are the models that render a particular statement true. So like you said, in this type theoretic approach, you're kind of building it in to the kind of moves that you're performing. So that's kind of what he's going for, that captures something about
Wait, that's what he's not going for, right?
what?
Sorry, I think I misheard you. Doesn't matter. Keep going.
But yeah, but that's basically what his whole kind of framework is, to draw out that idea.
He's trying to propose like an inferential view of that is based on this constructivist approach that you see in like intuition mathematics.
But so yeah, there I guess like I am curious how what he is saying relates to like the Martin Love's kind of meaning explanation for type theory. And I mean, Martin Love kind of invented type theory, right? And he like said that for him that's the quote unquote semantics, even though most mathematicians and most people, when they say semantics, they mean the Starskian kind of external meta language. And but there is
definitely seems to come from that school.
What?
He definitely seems to come from the Martin Love school.
Yeah, and there are other people like Doug Pravitz, and there is like if you Google proof theoretic semantics, it's basically this view like that the truth is not the conditions of making things true, but the truth is what counts as evidence. In other words, what you can recognize as proof of something being true. And that is like completely computational. That's not, you don't assume any external model of your language or anything like that.
So he cites per Martin Love here, I'm pretty sure.
He explicitly, I think, refers to the difference between the proof theoretic and model theoretic semantics as well.
So that's definitely where he's going with this. And that's what he means by internal, and that's why he's picking that. So he's kind of building his way there to that kind of idea. And along the way, he's trying to make this point like that in this particular truth table, I'm guessing all of you recognize that this can be interpreted as either and or, depending on how you interpret what each symbol means. So if you wanted to investigate a system and ask, well, what is it doing? You can't do that until you've given some kind of interpretation to the symbols in terms of true and false, which is what in a semiconductor, for instance, you have to pick which voltages you determine to be 1 and 0, for instance. So that's the kind of thing that is a sort of low-level version of the semantics that needs to kind of be put in or baked in, as in type theory. So yeah, that's the exact kind of distinction. You have formalism and external semantics on the one hand, and constructivism and internal semantics is kind of they're going for. Right. And we can skip this. Oh yeah, so this is where it comes up with, with the inspiration to the homotopy stuff. So I will aim to trace the homotopic version of type theory put forward by Universal Foundations as a way of making explicit the logical nature of a holistic computational worldview. There, if you like, is his mission statement. That's what he's trying to do here. May not always be completely clear about it, but that's more or less what it is. So this worldview, an intuitionistic view of computing, attempts to offer an internal semantics for computational reason, which specifies the role of mathematics and logic without simply subordinating the computational to the mathematical or rushing external content under the carpet. So that's kind of what that's what the goal here is. And then in this the sort of second part of the chapter, we talks about this, which you know, I'm very dismissive of, but he spent some time talking about it. So apparently Konrad Zuse is the one who first came up with this idea that like everything in the universe is a computation, and like the silly, there are these extremely silly things like the simulation hypothesis, which even David Chalmers has been writing about, and then the David Deutsch's version of the Church-Turing thesis, which is just absurd. But every finitely realizable physical system can be perfectly simulated by a universal model computing machine operating by finite means. What it has to do with physics is anybody's guess. And it actually reminds me of Max Tegmark.
Let me ask this, Johan.
Yeah, go.
Go ahead. No, go ahead.
No, I think I know what you're gonna ask, but go.
So what I was gonna ask,
Well, I was gonna say why I would just drop the word universal there and write like a finite state machine there, because I mean I think it's a theorem of like modern physics that any finally realizable physical system is a finite state machine, because you know there is a patch of space-time can have like only so much entropy before it collapses to a black hole. So if you take all possible space-time we ever need, let's say the observable universal, or let's go beyond, let's take like the causally, the thing that can have ever potentially any causal interaction with us in the past or in the future. That's a finite volume of space-time. There is, just imagine this is all one big black hole. That's the maximum amount of information that can be in the universe. It's a finite number. So yeah, you could definitely conceive of any subset of that as just a finite state machine. So I agree with that, except like cross out the word universal, like finite state.
Yeah, I mean, I feel like there's so many levels of
any
like,
finitely realizable physical system.
yeah, I think there's a lot of woolly-mindedness in a lot of this thermodynamics of information stuff, where the sort of thermodynamic concept of entropy is confused with the Shannon thing, and this happens a lot actually, even in this book. And I'm not very convinced of the physical meaningfulness of a lot of it. But I find it like it's very speculative, I think.
But you know, there is the information thermodynamics of information, right? Like it does take entropy to actually raise a bit.
Yeah, so I was reading about this. It's called Landout Principle, and he mentions it in his book. And again, I'm not completely convinced that it is the appropriate use of the two concepts, because the like even John von Neumann said, nobody understands what entropy is, and because of that, people will take the entropy formula from Shannon and use a sort of informational interpretation of phase spaces in thermodynamics. But there are a lot of sort of steps missing in this, as far as I can tell. But I'm not like an expert on that, but I am generally a little skeptical. But in fact, one of the intuitionistic arguments that Cavia brings up is this Nicholas Gissen's argument, which is analogous to this, which is something like the universe cannot contain infinite information, and for that reason, the even classical physics must be indeterministic. So he uses Brouwer's concept of choice sequences as a way of talking about like the finiteness of information. So basically getting away from the continuum, even in physics. But all of these things I think are a little bit questionable, sort of metaphysically questionable. But,
so
and like this Tegmark version is the most extreme.
The thing I was going to ask is, let's say that if you were to assume, if you agreed, for example, that there's like a discrete, like a minimally discrete time and space that you could break things up into. And that's the way everything was structured, and removing random phenomena, quantum phenomena. How do you escape basically the idea that this is a computable system?
Or
well, first of all, this is a common misconception about quantum mechanics, that it is based on discretization of time and space. That's not correct. But if you assume it, obviously, yeah, if you assume it, okay.
Loop quantum gravity is doing a lot better than string theory these days. And in loop quantum gravity, it is a theorem that the space-time is discrete. There is like a minimum
Okay.
So
But yeah, all these things are far, far removed from empirical, like experimental support. So it's
No, but what I'm saying is that,
difficult.
hold on. If you were to assume that there's a minimum discrete time space, quanta that everything is functioning on, at that point,
It's a tautology. Yes, it's a tautology.
no, forget about tautology. Like, why is it silly? What is so silly about the claim that everything can be simulated in print? What's so silly about the claim that this is actually just a computational process unfolding step by step?
Well, once you have all the universe in your domain of explanation, you have nothing left to simulate anything with.
But Johan, but let's say without like committing that like that black hole thermodynamics is correct, the quantum gravity is correct. Let's just at least acknowledge that like the continuous view of physics is at least in as much trouble as like this new quantum, like the fields where
Maybe, I don't know. Meaning like both quantum mechanics relies on continuous physics, so does special relativity, and these are pretty well verified. So like the complaints about them are more of a metaphysical nature.
No, well, actually the quantum, I mean, one of the problems with quantum mechanics is precisely that it like assumes this background time as continuous, which from general relativity just says like, no, you don't have a background time. Time is as much like subject to gravitational fields
right. So there's no theory of quantum gravity. So for the time being, wherever quantum mechanics can be tested experimentally, the predictions of quantum mechanics are generally borne out quite to 10 orders of 10 decimal.
Yeah, but even
those predictions a verification of the continuity of time?
Yeah, even the quantum, even like
quantum
physicists will admit that like those questions of like whether the time is continuous and so on, like quantum mechanics, if anything, is probably wrong about that. Like it's.
I don't think quantum mechanics can answer that, but both quantum mechanics and special relativity assume standard continuum based conceptions of space and time. The discretization of energy is different, and in field theory, again, it's different.
And is that assumption required because the underlying calculus requires it?
Probably, I'm not sure, but yeah, meaning, so people have tried to make discrete physics, right? In fact, David Deutsch is one of them, and they haven't reproduced all of physics using purely finitist methods. So there are lots of infinities that show up and things like that. So typical analysis is still very much useful.
Infinities that show up in experiments, or infinities that show up in the.
Well, they can't show up in experiments. They show up in
their math, which are not verifiable. Yeah.
In the form of singularities that actually like in the normalization group theory and stuff like that, they become quite important, those things.
But look, but regardless of the status of like the new quantum physics or old quantum physics, can we at least agree that like the continuous view of the universe as there being continuous space, continuous time is, it's as much like our own model making, our own like synthetic
100%,
construction, that there is no external, like let's at least not externalize that, let's at least say that this is our brain.
Yes, the map is not the territory.
That kind of ontology on the world.
100%. The map is not the territory. Unless you think that the map is the territory, because everything is math, like Max Tegmark things.
So with that view, then why is Gibson's approach inferior to like the traditional approach?
I don't think it is, but he has not necessarily reconstructed everything. He's kind of just given a way of thinking about classical physics as itself indeterministic.
So you said you didn't agree with it, which is why I was asking. So
no, I think that it's trying to explain something that doesn't necessarily need to be explained. Like the idea that because it's presupposing that the universe is computing itself, right? Because like universe does not need to store information about itself. Like if you frame physics that way, then sure, you have to answer all kinds of weird questions, like where is the information about the universe? But you don't have to frame it that way.
I don't know. What does that mean though?
What?
you can have a compact set of equations, for example, that if you're just saving state, if you imagine like the universe is expanding, like in the Turing machine sense of an infinite tape, like your state is just being written outward and outward and outward. Like, what is it? What is ultimately the objection here to, what are you objecting to? What's the beef?
It's not answering any physics question, right? It's just a piece of
No, but how, in what
trivially
sense is it,
speculative metaphysics.
no, but in what sense is it obviously wrong?
It's just trivially trivial doesn't mean wrong, right? Trivial means it doesn't do any work.
But all right, so we agree that you agree that it's obviously right?
No, it's trivially speculative. It doesn't do any work conceptually.
Maybe.
You can't leave it to.
And this is exactly the point. So trivially speculative metaphysics conflates modeling with explanation.
No, I agree. I'm okay with that. I'm okay with. No, hold on. I'm okay with painting it as trivially speculative. But like saying it's obviously wrong or silly or I don't know. I feel like that to me is the thing that like crosses the line.
I think it's silly.
Okay, so
that's just what I think.
I mean, I think it's up for debate, but it doesn't really. I'm not sure if it has any bearing.
Okay, I have a question. What does, like, what metaphysics is not trivially speculative?
Most of it is, which is why I'm not particularly into metaphysics, but
is the fact that we are living in like a continuous three-dimensional space and one-dimensional time, is that speculative or non?
Kind of, but at the very least it has some bearing on the physics that we find useful.
So we agree it's trivial. So that's trivial as arguing about whether or not it's a fucking Turing machine.
Right. Okay. Right. So he's basically saying that it's just a form of Pythagoreanism, which is like everything is numbers, like Tegmark. So I don't take it seriously, but if you like to, you can.
No, but you do take seriously the potential that, like, the universe is following a prescribed set of laws and unfolds as a sort of function of those laws, right?
Well, I'm not a determinist, so I don't.
No, but let's say you were. Let's say you were. At a minimum, you have to treat that as a not.
It's not logically incoherent to be a determinist. Let's put it that way.
Yeah, and you don't think it's a trivial position to claim that the universe is deterministic.
Right? No, it's not. It's like something that you believe.
It is trivially speculative, though.
Yeah, I mean, it's claiming. It's definitely claiming the map is the territory, but you're allowed to do that when it's metaphysics.
In what way is it claiming the map is the territory?
Because determinism is a property of models, right? Not of world. But when you say that the model is so
no, hold on, that's an assertion. Why is it not a property of the world?
Because what would count as making it, like, how do you establish the truth that it's a property of the world?
No, I don't know whether or not it's a property of the world. It could be a property of the world, independent of whether.
What I'm saying is that it is a property of models. Whatever else it is, whether it's a property of the world or not, is definitely a property of models.
Yeah, when I say, for example, the world is deterministic, I'm not saying it. I know it's a claim about the sort of ontological validity of.
Sure, yeah, that's what I'm saying.
Yeah.
So
I'm not saying that,
it goes
my
beyond,
knowledge of it is certain.
Yeah, it's like there's a difference between saying that the apple is red and the universe is deterministic, right? It's like in terms of how exactly one goes about establishing the truth of these things. That's all I'm saying. So yeah, that is. I think that I have anything else here. Oh yeah. So from the perspective of David Marr, who comes up, he mentions David Marr a few times. the way that Maurer breaks all this up is that a computation is like this top level description of what something does, and then you have an algorithm and an implementation of the algorithm. So like I often wonder about this, like when you talk about, like for David Maurer, sorting is a computation, and like bubble sort is an algorithm, and then the implementation is like whether you did it in machine code or in C or whatever. So from the perspective of the theory of computation, is it possible to make this kind of distinction, like between a computation and an algorithm, or between an algorithm and an implementation? Like in a Turing machine, for instance, can you make that distinction?
That's actually an interesting question. If you like, arguably, yes, I guess you could, right? It's almost like having a type that you want your program for a function to have versus having a function. You can consider, you can basically write code that relies on having a function of a certain type without necessarily having a function of the type. And so you can assume you have a computation that solves a given problem without necessarily having the algorithm yet.
Right. That's interesting. But then what you've done, if you've just written the type, like the function, without actually filling in what it does, you've just specified the type dependency. It doesn't actually do anything yet, right? Until you've like filled it all up.
Well, mechanistically, it may not do something, but the fact that it fits in there and I can proceed further means it has done something logically.
Yeah,
So-
well, and actually you can have the sorting is a type. You take a list of, let's say, a list of integers, and you output a sigma type where you have a pair consisting of a list and the proof that every element of the list is less than or equal to the preceding, to this or like the next element in that list.
Right. So even without, wait, the proof is, so in that particular kind of example, the proof is an algorithm, right? If not an implementation, at the very least, it's an algorithm, right?
But the logic doesn't depend
Because
on
it's constructive.
the logic doesn't depend on the algorithm, as long as the type is like you can replace it by a different algorithm that gives you the same type.
Yeah, you can slightly change that formula, that type, in a way that there is no algorithm that can realize it.
Okay. So yeah, then it becomes a little bit like a placeholder, right? Because it hasn't, like, if you're actually going to use it, you don't actually do anything, right? Yeah.
Well,
Okay.
but the question is, does the placeholder itself serve a semantic value, right? Or is it just
Yeah.
like that something is going to bridge this gap?
Well, that's actually the Hilbert view of logic, is that actually every assumption, every axiom you make is like a placeholder that you can then use to draw further inferences without bothering how you ever come to know whether that assumption is true.
Yeah, but last week I looked at Hilbert's because this book criticizes the Hilbert's formalism, but I actually think Hilbert's pretty clever, and the paper where he kind of lays this out is really good. And he talks about, I mean, there's this, in my opinion, there's like a connotative difference between what Brouwer was doing and what Hilbert's doing. So Brouwer was very much of the opinion that, that these mental ideas, intuitions that we have to construct, and only those become real. But because he didn't like all this, all the stuff that Cantor was up to, whereas Hilbert did. But Hilbert agreed with Brouwer that you couldn't really conceive of an actual infinity. But the way that he talked about it was using something called the method of ideal elements, and which is that basically the lesson of imaginary numbers, which is that we don't actually have any mental picture of the square root of -1, but we just kind of, in fact, he uses the term adjoin. We sort of adjoin these ideal elements to our system in order to preserve Aristotelian logic. So it's interesting that, like, if you think about what both Hilbert and Brouwer did when they're confronted by these strange things, is that, like, Brouwer rejects classical logic, and Hilbert rejects like the coherence of something as an intuitive concept. And those are the kind of the two trajectories here. And for the computer scientists, I guess, because construction is so useful and important, that's how kind of Brouwer has made this comeback with all these constructive proofs. Yeah, so I think that's. Oh yeah, so this was kind of an additional question I had, which kind of goes back to the philosophy of mind and the symbolism thing, which is, are there computations without representation? And I guess the answer with the empty Turing formalism is yes, that the symbols don't have to mean anything. And I was thinking of this thought experiment.
Symbols
Like,
don't
if
have
you
to
could,
mean anything is not the same as this, right?
what?
Symbols don't have to mean anything is not equivalent to having computation without representation.
Well, so a representation typically is a representation of something, right? So so if you don't have that, you can still have symbols. They just don't mean anything.
I actually see the other way around, which is that you have, so not having a representation doesn't mean that if we go with the idea that computation has semantics embedded in it, right?
Yeah.
Then can we still have a computation with a representation? I think we can, because representation in a way is just a way of having reference to those objects, right? So you can have meaning embedded in the computation without necessarily having explicit reference to those objects.
Yeah, I think that's definitely what Cavia is going for, because that's consistent with the internalism thing.
Wait, can you guys elaborate a little, because I mean, so like, let's say I look at the question, I think the answer is no. Why? Like, how can you? Isn't by definition computation acts on representations? What's the argument?
Wait, so
what's the argument against that?
But so, in what sense are the Turing symbols representation? Suppose.
I think I'm sorry, you're going to say something. So for me, representation is more of a representation of, going back to the beginning, a state, right? A state has a representation that we use to refer to it. When I say that, when I say 2,3 as a point in two-dimensional space, 2,3 is a representation that refers to that particular point in that Cartesian space. So let's go with the idea like that somebody was talking about, how language models today have this, let's say they have the semantic of English or whatever that they've learned, right? Which is embedded in this like high dimensional space, Word2Vec style or whatever. Then the semantics exist there, right? And there are ways we can test it. It is possible that there is a and I think Johan, I've talked to Johan about this earlier, right? Like if you go to a point in that high dimensional vector space, it may not always be the case that you may come up with a word that refers to that point. But the lack of the word doesn't mean that that point doesn't have a semantic content in it, right? There may be like a point between like queen and king and man and woman and whatever somewhere in between there, and the fact that that point can be like that exists doesn't mean, even though we may not have a word that can actually like refer to it, doesn't mean that.
Oh, I think I see what you mean. So like you have an algorithm, like your language model computed something that doesn't have a word, but just because there isn't a word doesn't mean that what it computed isn't like a real computing or a real computation.
But
Yeah.
it also feels like, from reading again the brief course, the intro of the Cavia book that like I did read, and I promise I'll get to more.
I mean, you probably won't like the book, so maybe you shouldn't read it.
No,
No, that's why you should read it.
it only makes it more likely that I'm going to read it. So, but the thing is that like, it feels like the question comes down to, if I have a random Turing machine with some random set of operations operating over some random set of states, can we call that a computation? If those states don't refer to things in the world, if they don't,
most people say the answer is yes, so that's fine.
and yeah, to me, it's nevertheless a computation. It's a
Yeah, I mean, I
process.
understand why people say that. So,
Yeah.
But at the same time, despite the fact that you agree that that entails that everything in the universe is a computation in some sense, if you add the finite part, but at the same time, it is not a useful way to talk about what the mind is doing, right?
It's not a useful way to talk about what most things are
Why?
doing. In the same way that like, when you're talking
my
about
question is
chemistry,
this, right?
no, in the same way that when you talk about chemistry, you don't make reference to like,
Right, but
like
I agree.
very
Yes. Yeah, you don't
physics
start
and,
with yeah.
like when you're talking about
Here's the question.
statistical
question.
mechanics. Yeah.
Isn't there something similar about language and computation? So when we are thinking, we're manipulating symbols, right? So why wouldn't you reach to computation for at least an inspiration for your mental theory?
I think there's a sense in for manipulating symbols. I think it's done in a way that's very weird and not one-to-one with the way we think about like logical formulas and so on and so on. Like, first of all, syntactic like sort of correctness of sentences in the first place. When I say I bit the dog and dog bit I, right? Dog bit I is not syntactically correct, right? Nevertheless, you would probably understand if I said dog bit I, you would get like the dog bit me, right?
Yeah,
And so there's
I might think that you were having a stroke.
maybe, or you might,
Okay.
or you might,
Or
think
it was
like,
In
already
either case,
wrong.
in either case, there'll be some meaning that will be extracted from that sentence.
Okay, yeah. So
Yeah.
so what you're saying is that there's some surface level phenomena in language that don't easily map onto rule-like structure.
Yeah. So, and this to me became like really painful when like one of the things that Steven Pinker became famous for was like this thing of like verb microclasses, right? And he had the study, and it was kind of ripped off somebody else. And let's probably not publish this Zoom video on YouTube because
I can stop the recording.
I may or may not. Yeah.
I can stop the recording.